So let's start doing that. So this is like 4 or 5, just like mini lessons, I guess, we're going through. So if I look at this first one, it's just a matter of understanding what they're asking. So they're saying g of x equals this integral from -2 to x of f of t, and then this is the graph of f of t. And down here they say integrate or evaluate g of 2. Well, g of 2 means you would plug in 2 for x. So you just put a 2 there instead of the x that they had up there. And then we talked about this a little bit, but I'm not sure how much. Remember with derivatives, how do you take the derivative of a graph? Slope. So derivatives is slope. How do you take the integral of a graph? Integral's area. So all they're saying here is find the area between -2 and 2. And you can literally just count boxes. There's no equation, there's no integrating. You're just going, all right, well, -2's there, 2's there. Just count the boxes in there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it'll be like 16.5. Easy enough? Do the next one. What do you get? 5, right? Oh, that was like 5. I thought you had a question. All right, 5, yeah. So you just count the boxes. We're going from -3 to -1. There's 5 boxes there. There's one rule that is going to come up in a mini lesson in like 5 minutes. But here's a sneak preview. If I asked you, so this number on the bottom is always the one on the, not always, but it's typically the one on the left. So you read integrals left to right like you would read a book. If they flip-flop it, where this is kind of goofy because it's negative numbers, but let's say I had the integral of 2 to 5 times f of t of dt equals 8. That's left to right, that's our typical order. You know, 2 is lower than 5, so you read 2, 3, 4, then 5. If they asked you for the integral of 5 to 2, you're now reading it backwards. What do you think your answer is? -8. So you got to pay attention to the order here. The lower numbers should be on the bottom. Typically, if it's not, which they will do to mess with you sometimes, you just take the negative of the answer. So the rule there, if you want like a rule, the integral from a to b equals -1 times the integral from b to a. So it's just like you're reading it backwards, so your answer becomes backwards by putting the negative sign there. All right, let's keep going. This is integrals with like area formulas, so it's almost like a geometry type thing combined with the calculus notation. So from -3 to -1, so I'm looking for this little piece here. I want to integrate it from -3 to 1, so I want -3 to -1, so I want to find the area, right? So that is a half of a circle. What is the area of a circle? Not 2 pi r. Pi r squared. This might help. 2 pi r is circumference. This might not help. What's the integral of 2 pi r? Hello? Yeah. Sure. Okay. Yep. What's the integral of 2 pi r? Pi r squared. It's kind of cool, right? So this is circumference, this is area. So it can be found. You found the area of the circumference. You get the area. So pi r squared, but we only have half a circle, right? We're just looking below. What's the radius of that circle? Or of that semicircle? 1. 1/2 times pi times 1 squared. Just be like pi over 2. Or 1/2 times pi. Easy enough? So like, I don't think any of these are really that hard, but I just want to show you before I was like, here's what you have that I've never taught you. Go ahead. Do the next one. Wait. Go back to the last one. Don't even go back. Just let me go back. If I made that from -1 to -3, what would the answer be? -5. So I flip it around, you flip your answer. My bad, I usually put one of your tests on there. Solid, right? I count that right? You didn't get 7 or you did? Good? You didn't get 7. What'd you get? So this is 4, right? Right there. This is a triangle with a height of 2 and a base of 1. So half base times height gives me 1 there. This has a height of 4 and a base of 1. So half base times height gives me 2 for that part. That's how I sectioned it off. Like, there's different ways to split it up. Does that make sense, Jess? Oh yeah. That's like the jacket. Alright. Next page. Oh, that's cool, right? So this is just getting at the idea that you can combine within the same integral or like 2 different integrals. So this would be the integral from -3 to 0. So is that the typical order or is that reversed? That's typical because the lower number is on the bottom. -3 is lower than 0. So what's the integral from -3 to 0 of h of x? You see where we get -1 from? This is h. From -3 to 0 is right there. So -1 is that piece right there. Plus, for g of x, what's the integral from -3 to 0? 3. So it's this piece right here. So -1 plus 3, 2. Easy enough, right? Bottom one. We've talked about this before. If there is like this tricky little rule, you don't really need to use it, but what could I do with that -5 if I wanted to? I'd like pull it outside and then do the integral and multiply by -5. The point is you would just find the integral here from 3 to 6 and then do what with it? Multiply it by -5. So that'd be 30. What if it was the integral from 6 to 3? -30. Is that right? It's like 3 lessons we've done already. What, 5 minutes? Remember that you're dealing with like rectangles here. If I'm going from 2 to 2, what's the size of the base? 0. So therefore, what's the area? 0. So if you're going from 2 to 2, you're not going anywhere. You're not accumulating any area as you go. That's just 0. If it's 10 to 10 or 7 to 7 or whatever it is, if it's the same number, there's no area to pick up and it's just going to be 0. Try the bottom one. -6 or +6? Positive, good. So you got to pay attention to usually the -40 on the bottom is lower. They flipped it, they put the smaller number on the top, which means you got to take your answer, which was -6, and flip it and make it +6. Top one's a little bit tricky. Are any of you in Baden's CIS in the afternoon? I'm studying, I guess. What do we do? Oh, even morning?
Yeah.
Same thing though, right? What do we do?
Yeah. They just did evaluation of their free library. They had to fix a spreadsheet or something. It took all hour. I don't know if they can do it without a free library.
Oh, like you had help a lot?
Yeah. That's awesome.
Okay. This top one, they don't split it up the same way on the question as they did on the graph. But what they're essentially asking you here is to find the integral from -2 to 7. They split it up, again, a different way than they did up here, but can you see how if I combine -2 to 2 and 2 to 7, that's essentially just saying, give you the whole thing, -2 to 7? And we can do that. Even though we split it in different spots, if I'm going from -2 to 7, what should my answer be? Not 10. Not -10. 4. Because anything below the axis has to count as negative. So I'm finding the area from -2 to 7. That's all they're asking me for here. They're just asking it a different way. And then there's a +7 up here and a -3 down there. So let me write another one of those. Let's say -6 to -3 plus -3 to 3. Try that one. So they're really asking you for the integral from where to where? -6 all the way to 3, which we can look at the graph and be like, okay, 5 below, 7 above. How many got 2 for that? Okay, one more. Find the integral from 7 to -6. So that's upside down, right? Typically be -6 to 7, but you're finding this whole area. So we got 8 below, 7 above. So this, if I were asking it in the correct order, it would be -1. Because I'm asking it in the opposite order, it's 1. Okay. Should you do the bottom one yet or not yet? What do you get? Should be 0. 15 to 17, like the way that's designed, you get this little triangle above the axis, the little triangle below the axis, and those go away. And you get 0. Do this. Write another integral with that graph where the answer would be 0. The integral from what to what? G of x times dx also equals 0. So A is the same two numbers. Well, you could. I could go 17 to 50. What do you got? 3 to 5, or 5 to 3, right? I mean, you could flip it either way if you want. It's opposite of 0 is still 0. Okay? Alright. So there's one more of those on the top, and then these next two are different types. Do that one at the top, and then I'll explain the bottom two. it's above, the other 7 is below. So that counts as negative. We're going from there to there. Those good? The area ones? Reasonable? Okay. So these you gotta do a little more work. I'm gonna like work out the algebra part over here. So what they're telling me here, and the AP test loves to do this, and I'm not a fan of the way they write it, but strangely enough, they didn't ask me. So if little g is the derivative of big G, that's what they're telling me here, then if I integrate little g, where do I end up? So what they've done here is set up this, okay, G, little g and capital G prime are on the same level. They told me they're equal, so little g and capital G prime. Well, where would G go, capital G? Up a level or down a level? If I integrate, I go up. A derivative, I go down. So capital G is up here. So whether I'm starting at G prime or I'm starting at little g, the way I get up a level to capital G is to integrate. So if I integrate little g over here, I get capital G. And I want to integrate that from -1 to 7. Should I walk through that again? I'm not sure how much we've done with the capital and the lowercase really yet. Let me walk through again. So they're telling me this. Lowercase g is capital G prime. Well, how would I go from G prime to G? I would integrate. Therefore, how would I go from little g to capital G? I would integrate. Therefore, if I integrate little g, what do I get? I get big G. Well, what is big G? Big G is x plus 3 squared. And I want to evaluate that from -1 to 7. So we're doing the definite integral. They're just kind of set it up a little goofy. Like I never even knew what little g of x was. I just know that when I integrate, this is what I get. And then I can do my plugging in. So I would do 7 plus 3 squared minus -1 plus 3 squared. So 7 plus 3 squared is 100 minus 4. So your answer would be 96, but that's not, the answer is not really what I'm worried about. Is the process, is what I'm doing, make sense? Questions on that one? That's a little trickier, I think, than everything else so far. We'll try the bottom one then. So to get from h prime to h, I have to go up a level, that means integrate. And little h is the same as h prime, so to get from little h to capital H, I also integrate. So when they tell me here to integrate little h, that means that I end up at capital H from -1 to 0. Capital H is 3x squared minus 6 from -1 to 0. And then I can do my plugging in, so 3 times 0 squared minus 6 minus 3 times -1 squared minus 6. So this is -6 minus, this would be minus -3. So So negative 6 plus 3, did you guys get negative 3? Questions? Okay. The last thing, and this might be the toughest one, I don't know. We'll see. Is a piecewise. So they're asking you, in this top one, for the integral from negative 2 to 2. But the equation changes at 0. So you're going to have to set up two integrals. One that goes from negative 2 up to 0. Like you've got, they're asking you negative 2 to 2, basically. But then something happens at 0. So it kind of splits your integral into two parts. So from negative 2 to 0, we're going to integrate which one, the top or the bottom, and why? So we're going to have this negative 2 to 0, we're going to integrate one equation. From 0 to 2, we're going to integrate the other equation. From negative 2 to 0, which equation are we going to integrate, top or bottom, and why? The bottom, why? Because x is less than 0. So x is less than 0 matches up with the negative 2 to 0 portion. So up here, I'm going to integrate 3x squared minus 2x. And then the 0 to 2 fits in with the x is greater than 0 part. So here, I'm going to integrate 6x. And then you would just integrate both those, plug everything in, add those two numbers together. Is it okay if I stop there and say you can do that on your own? Or should we do that? Let's do it. All right. So this would be, what do I integrate? What do I get if I integrate 3x squared minus 2x? X cubed minus x squared from negative 2 to 0. So plug in 0, which is 0 cubed minus 0 squared. Plug in negative 2. Should have left a little more space here. It's negative 2 cubed minus negative 2 squared. That part's 0, which is nice. And this will be negative 8 minus 4. So 0 minus negative 12. This part up here is 12. But that's just like the first part of the integral. And then do the same exact process on the bottom. So what's the integral of 6x? 3x squared. From 0 to 2. So 3 times 2 squared minus 3 times 0 squared. That would also be 12. Well, that makes our answer then 24. Make sense? Questions? Where'd you do this? Why'd you do this? What's happening here? What's an integral? How do you add? What's a line? Let's go through that, yeah. Anything I can help with on that one? Try the next one. I think that little number line thing at the top helps. You don't have to do it. It's not like that counts for like showing your work or anything, but it just helps me kind of like organize what goes where. done yet? Right, good. Just want to check my answers. First of all, was the setup okay? Like just starting off knowing what to put in each spot, was that part okay? Alright. Everybody else done and got the same answer as me? Oh, wait. It's entirely possible I screwed up. I was like, felt like I was doing too much in my head, so I wasn't entirely confident. I think we found the hardest part. What can I help with? Because people are stuck, not getting the answer, like looking around, looking at the board. What's the problem? Where can I help? What questions can I answer?
Can you go through the left side? Just distributing and everything.
This part here.
Yeah.
So as you integrate, you get the same thing I got when you integrated.
Yeah.
1 to negative 4. So then 1/2 times 1 squared minus 3 times 1. 1/2 times negative 4 squared minus 3 times negative 4. And then, so this is 1/2, right?
Yeah.
Minus 3, so negative 2.5. Negative 4 squared is 16. Half of that is 8. This would be plus 12. So 8 plus 12 is 20. Combine those. What else can I... How many have the same answer? So it's only a few people, so the rest of you are stuck. So how can I help is what I'm asking. Yeah. So this part here. So remember, this 3 has power. You take the second root of 4. So what number does the second power gives you 4? It's 2. And then you raise that to the power on top. So what's 2 to the third? 80. That's negative 2. Negative 16. And then 1, if it's a 1, it's easy. 1 to any power. Like you can multiply by 1 by itself as many times you want. Start taking roots of 1 as many times you want. It's 1. You know, square root of 1 is 1. 1 to the third is 1. Times negative 2 is negative 2. So that's plus. Does that help, Naomi?
Yeah.
It was like
Well,
the least convincing.
I did the first step wrong, so all of it,
Oh,
the rest
gotcha.
of it's messed up. So I'm trying to sort out in my head and on the page what I understand and what
Right.
I don't.
Anything else I can help with on that one? Sure. Okay, try the next one. Did you want that there, anybody?
Yeah, it's just.
in the con, don't kill yourself if you have like 95% of them correct. You know, I'm not going to look at it and be like, well, you missed one here and one here, you don't get to do the gateway. You know, as long as you're pretty darn close, if you got one missed on a couple different sections, it's not the end of the world. I don't know. It's like 20. Really? Man. Sure. But like the worksheet we just went through like 6 sections. So up until this, it was simple, right? Like just adding up the areas and stuff, yeah.
20 minus 1.5 is 7.
Oh, yeah. Thank you. So if you're done with this, I'll run con the rest of the time. If you have questions on this, please let me know. We do have a lesson tomorrow. You know, start grinding away at that con so you can get all 3 attempts at the gateway. You will see a practice gateway on Tuesday, so you know like how many and what different types of problems to expect. Do you have a question? Yeah. So I add 1 to the power, get 0, multiply by the reciprocal, which doesn't work. So that kind of reminds me, oh yeah, that's ln's. So the integral of x to the negative 1 is ln of x, and the 5 just drops. And then I gotta plug in the 6 and the 5. So this is, you know, plugging in the 6 and the 5, I'm just like throwing them in there. So 5 times ln of 6 minus 5 times ln of 5. And then remember that rule that when it's division, or when it's subtraction, when you're subtracting logs or natural logs, it combines into a division problem. So the 5 stayed out in front, and then I'm dividing the 6 and the 5 because subtraction combines to be division. If you think through why that happens, it's because these are really powers, and when you're dividing, what do you do with the exponents? Like if you're dividing the same base, what do you do with the exponents? You subtract them, and that's why this subtraction and division thing matches up like that. And then, you know, I don't have a calculator or anything, so I'm just leaving it. There's nothing else I can do from there. Does that help? Okay. Yeah.
Can you do the other side, but mainly the first part where you plug in 5?
Where I plugged in 5. So 5 squared, 25. Half of that's 12.5. 4 times 5 is 20. 12.5 minus 20 if you actually go on subtract, which I did it essentially. It was negative 7.5. Is that right?
Yeah, I just did it with fractions, so just take it.
Oh, so it'd be like 25 halves minus 20. So it'd be 25 halves minus 40 halves. So negative 15 halves. Then that's negative 7.5. Anything else here? Okay, so yeah, start working on it. We have a section tomorrow. I think it's actually pretty quick. I don't think it's like a very in-depth thing, so you'll hopefully have like, I'd say maybe half the class tomorrow to work on con also. This is kind of, I mean, we're kind of pushing, I'm compressing a lot into a little bit of time, so I want to finish before break. So it is probably a little more than normal, but it is what it is. So when it's greater than 5, it should be this way. 16 boxes of the rectangle. And that triangle has a base of 3 and a half. So 1/2 base minus 9 would be 1/2 base minus 1.